Alright, the last case we have to talk about are indeterminate forms where we're doing infinity as an exponent, or infinity raised to a zero power, or 0 to the 0 power. And what we're going to do here is, in order to try to get it into a form where we're allowed to use L'Hopital's rule, is we're going to take the logarithm of the limit. We just have to remember that once we then use L'Hopital's rule to find that limit, that's really, I then have to raise e to that power to get the answer to my original limit. So for example, the first limit here, as x approaches 0 of 1 plus 1 over x all raised to the x, well, as infinity is approaching, as x approaches infinity, my inside approaches 1 raised to the infinite power. So that is in this form. So if I take the natural log of all of this, I can move the x down in front because that's the power property for logarithms. So this would be the limit as x approaches infinity of x times the natural log of 1 plus 1 over x. Well, this would be infinity times 0, so that's still not in the form I need. So I'm going to instead say, instead of the natural log times that x, it's going to be my limit as x approaches infinity of the natural log over 1 over x. And now that it's in this form, I now have it as 0 over 0, which means I can do L'Hopital's rule. So the limit as x approaches infinity. Derivative of natural log on top will be 1 over that times the derivative of what's inside. And then for my denominator, derivative of that is negative 1 over x squared. Well, the negative 1 over x squareds are going to cancel on top and bottom, leaving me the limit as x approaches infinity of 1 over 1 plus 1 over x. Well, as x approaches infinity, the 1 over x goes to 0, and this goes towards 1. So now what this means I need to do is I need to undo the natural log I did at the beginning. And so my original limit here, whoops, sorry about that. My original limit here is really e raised to this power. So my limit is just going to equal e. Over here to my right-hand example, again, I'm going, if I plug it in 0, this would be 0 to the 0 power. That's one of my indeterminate forms. However, I can't use L'Hopital's rule in that form, so I'm going to take the natural log and do the limit as x approaches 0 from the right of x times the natural log of x, because of the power property for logarithms. Well, this now becomes 0 times negative infinity, because then can't take the natural log of 0, it has a vertical asymptote there. So I'm going to rewrite that as the limit as x approaches 0 from the right of the natural log of x over 1 over x. Well, now I've got negative infinity over infinity. That is an indeterminate form that I'm able to use L'Hopital's rule on. So I'm going to do the derivative of the numerator and denominator. So limit as x approaches 0 from the right of 1 over x over negative 1 over x squared, which would equal the limit as x approaches 0 from the right of negative x. And now I can do substitution, and that's 0. But then I need to plug that back in to my original and realize that this was after I took a logarithm, the natural log, so this becomes the exponent of e. And so the limit as x approaches 0 from the right of just x over x is really e to the 0, which is 1. And for a final example here, I've got the limit as x approaches 0, or approaches infinity of x to the 1 over x. So this would be infinity to the 0 power. So I'm going to take the logarithm and this do the limit as x approaches infinity of 1 over x times the natural log of x. Well, this is now 0 times negative infinity. That's another indeterminate form, but still not in the form I need it in. So I'm just going to multiply those two together, and the limit as x approaches infinity of natural log of x over x. Well, this is now infinity over infinity. I can do L'Hopital's rule, and that'll be my limit as x approaches infinity of 1 over x over 1, which is just 0. But again, I have to put that back into my original limit and realize this was after I took a natural log, so this is really e to that power, which is 1.